times valuable, right? Okay. All right, let's have some fun. I will, but we're going to go over the evens as well. So being that you're here, you're getting the points for it. Deal? So page 111 you claim, right? It says, problem number 1, look at the data carefully. Does this data set appear to have outliers? If so, which values? It does, I guess, let me see yours real quick. That's it right there. Okay, cool. I just want to make sure I'm on the right page. So it appears to have an outlier. That one way out there at 11 appears to be an outlier, I would say, because it kind of, that outlier out there, what it's going to do is actually going to pull the mean to the right because it's an outside outlier. Okay. Use your calculator to find the mean and the standard deviation. Or median, excuse me. All right, so if I were to use this on a calculator, I am going to try out my buddy called Desmos. Is that trash? Yeah. Sorry about that. Let's see if Desmos can figure out our information, but I have to use my keyboard. Anyone else come in that mess? Okay, good. All right. So the mean is relatively simple to figure out. You can do it a number of ways. I'm going to choose to use Desmos to stay consistent. So what I'm going to do, if I want to use Desmos as a calculator, it'll work fine. I don't have to use it as the graphing. So if I just plug my data in, 10.1 plus 10.2, 10.2, 10.2. Oops, I have an equals there. That's not going to work. Plus 10.2. And then 10.34 times. I think I have that right. 1, 2, 3, 4. And then 10.4 5 times. That's 3. That's 4. That's 5. 10.5 twice. 10.6 3 times. 10.7 and 11. So notice I put it all in parentheses. Right now it tells me that the summation of all my numbers, if I put them in correctly, is 208.4. And then you have to figure out how many pieces of data you have. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I have 20 pieces of data. So then I can go divided by 2, or 20, excuse me. Did that work? Uh-oh. Did that work? Yeah, 10.42, that works. So our average, our mean is 10.42. Now, in order to find the median when we look at it, so do you feel comfortable finding the mean?
Yeah.
It's pretty easy. Okay. Of course, you can use your own calculator. You don't have to use Desmos. In order to find the median for number 2 is a little, it's more tedious. So the median, we said the mean is x bar, which is 10.42. And then the median, so there's 20 numbers. So I can count up to the 10th number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if I count from the other side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the median is exactly in the middle. It falls into the column of the 10.4s when you count it up. Depending upon which way you counted, it could have fallen here or here. Well, if you go 10.4 plus 10.4, you get 20.8. 28.8 divided by 10 point, or by 2 is 10.4. So the median is sometimes harder to find because you're trying to find the middle, especially if you have an even number of information. You have to find what your middle data is. Now I'll try not to spill coffee down in my front of my body again like I did yesterday, second period. That was fun. Interpret the mean and in the context, explain what it measures. So the mean was 10.42. This was times for a 100-meter sprint. So this just means that the average sprint time is 10.42 seconds as far as the data we collected. I don't know if that's good or bad. Any track people in here? I don't know if that's a good one or not. Sounds fast, but I don't know. Number 4 says interpret the median in the context. Explain what the median measures. Okay, so the median is 10.4. The median is the middle data point. That means half your data should be above it, half your data should be below it. That's all it means. Okay, it's at the 50th percentile, which I think is a question that comes up. So the median is always at the 50th percentile. 50th percentile means half the data is above, half the data is below, things like that. So I guess number 5 says a percentile is a percentage of data that lies below a certain value. Find the percentile for 10.4 and then explain what this percentile score in context of the question. So 10.4 is the median. That means half the data is above it, half the data is below it. Okay, that's really all you have to go with. Okay, there are some ways that you can kind of dork around because you're not sure exactly which 10.4 is the exact answer because there's 5 dots of it, but I think we nailed it. And then explain the meaning of the statement below. Pretend you're explaining this sentence to someone who doesn't understand. The median income of police officers in Detroit, Michigan is $46,400. It's kind of low, I think, but who knows? But I'm just saying for a full-time job. So what do you think? How would you explain if I told you that the median income of police officers in Detroit is $46,400? How would that mean? Use your words. Anybody's. Well, what is the median just in definition? The middle. So if the median was 46,400, that's at the 50th percentile. So what does that mean? Do all people make more than that? All people make less than that? And a certain percent make more or less? Or what do you think?
That's the average.
That's not the average. The average is the mean. So that's the middle. So if I had 10,000 pieces of data, or let's make this easier. If I have 11 pieces of data, the sixth thing would be, the sixth part, if I had 11 pieces of data, would be the median. Okay, so that means half of my information is below, half is above. So if the median is 46,400, that means half the police department makes less than that, and half the police department makes more than that. Huh. gosh, these days with minimum wage going up, I don't. What is minimum wage these days? Does anyone know? $12.35. All right, hang on. Let's see. How does this deal with the contest? So $12.35 you claim, huh? So $12.35 times. Where's my times? Times a 40-hour week. Return. Why is it not working? 12.35. Can't have nice things right now. 12.35 times 40. It's 494 times 52 weeks. So I guess if you make minimum wage, it's just under $26,000 if you had a 40-hour. Huh. I was just trying to figure out the context of that 46,000 seemed like a good figure or not. I don't know. I guess it's more than minimum wage here, but the average time it takes to drive to the Dallas airport from downtown Dallas is 27.4 minutes. So now we're talking about an average. So talk to me, what does the average mean? If I found 100 drivers, go ahead.
The expected time.
It's the expected time. Good. Oh, you're so awesome. Make sure that's on your notes for the quiz because expected, okay? Expected time. So the mean and the expected time, same thing. So if you were living in downtown Dallas and you're like, I have to get to the airport, someone could say, and I know that you could do this on your phones as well. You'd say, how long will it take me to get to the airport? And it's going to tell you the time. A lot of times traffic is flowing correctly. It should tell you 27.4 minutes. Unfortunately, you get all kinds of other people who are, someone's changing their tire on the side of the road, so everyone locks up their brakes to look. Because changing a tire is the most interesting thing in the world. So that might change your time. But it's the average time. It's the expected value. Very good. Very good. Problem number 8. I know we didn't do it. It says Jim's ACT score was at the 46th percentile. Now, we haven't really talked too much about percentiles other than when it meant 50%. What does the 46th percentile mean where you have basic knowledge? Because I said the 50th percentile, half is above and half is below. So if you fall at the 46th percentile, are you higher than what the median should be? No, you're lower. Okay? So that basically means if you're at the 46th percentile, 45% of the population did worse than you. And then that would mean on the other end, 54% would have done better than you. Okay? Sarah's test score was an outlier in her physics class. We don't like Sarah. She changed the curve. Okay? So if it's an outlier, it doesn't tell us which way the outlier was, but the outlier was either Sarah did incredibly well compared to the rest. So let's say the average was a 60% and Sarah busts out a 98%. That might be an outlier. But if like the average on a test was 91% and Sarah got a 3%, that also could be an outlier. So we're not quite sure. So outlier is definitely way outside of our data range. And then we have the following back-to-back stem and plot, meaning there's two pieces of data that we're using the same stems for. Calculate the mean for the pulse rate before exercise. I don't know if I have to necessarily do that, but what you would do in order to find the mean on number 10, pulse rate before exercise, you'd have to go take all your data. You go 50 plus 52 plus 53 plus 58 plus 59 plus 60 plus 60 plus 61 plus 64 plus 66 plus 66 plus 67 plus 72 plus 76 plus 79 add that up, divide by however many there is, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Divided by 15, and that would tell us, if we did that all correctly, that we should come out to about this for our mean, okay? Which is our expected value. I like it. Interpret the mean in the context. In this case, you would say that your expected value would be 62.7. You would, if you were checking the pulse rate, you would expect it to be right around 62.7 for a person in this scenario. Calculate the median pulse rate for the exercise. So I would have to find the middle data of that, and I believe it is at 61. So it's exactly in the middle of the data. So what you could do is, if you wanted, you could list out 59, 62, 64, 67, 68, 68, 71, 71, 74, 74, 78, 82, 84, 89, and 92. Find the middle of that, and you would find the median. If there's two numbers, you add the two middle numbers together, divide by 2, so the median is 61. And what does the median mean in the context of this problem? Half the heart rates are above 61 and half are below 61. And 14, I haven't really taught this concept yet, so let's make sure. So we want to calculate somebody with a rate at 68 after exercise. So I go find 68. So 68 is 1, 2, 3, 4, 5. 1, 2, 3, 4. It's 5, and there's 15 numbers. So if you were to do 68, in order to get to 68, there's 4 numbers prior to the 68 out of the 15 numbers. So if you do that math, it comes out to this, but I don't think we'll have that on a quiz Friday, okay? I think quiz Friday. That's what my knowledge is for day. And then interpret the percentile of this context. So if you found that the 4 out of 15, then 26.7% of all pulse rates were below 68%, or 68 beats. Okay, we good? Happy? Now let me just flip back here. What do we have here? This little Jim Dandy seems like a good idea at the time, and then measures of spread in 7. Okay. All right, so I think I'll allow you to work on page 113 and 114. You definitely have to use Desmos, and you have some time to work on it. And this is a review. Tomorrow will be a second review that we will actually, or we'll go over the review, and then on Friday, make sure we start having our half sheets of paper ready. It could be the same one you've used. You just add to it. You can make up a new one. But anything so far in the class is good for the review, okay? Or put on your sheet. Save.